Hello students, welcome to A to Z Learning Hub. Today our second class of set. In previous class, I have told you about what is null set, what is finite set, what is infinite set, what is an equivalent set, what are equal sets. I have already told you about this. Today, we will start about Singleton set. Singleton set. You see, a set which has only one element is called a Singleton set. What is its example? You see, suppose A is a set X such that X is both even and a prime. This is a singleton set because we can write A is equal to what? 2. 2 is only one number which is both even and a prime. In similar manner, you can give any example. Suppose X is a set, you say Ram. This is also a singleton set. That means you take any set which has only one element, then it is called a singleton set. Next come to your set of sets. Set of sets. What is a set of sets? If every element of a set is itself a set, is called the set of sets. For example, A is a set, I write, suppose A is equal to 1, 2, 3, that is your 5, 7 and 9. You see, this set has 3 elements, that is 1, 2, 3, 5, 7 and 9, and each element is a set. So, A is called set of sets. In similar manner, I will write X is equal to, suppose Indians, Americans, Russians. This is also a set of sets because Indian means all the people of India, American means all the people of America, and Russian means all people of Russia. This is called set of sets. Next come to your subset. What is a subset? To know detail about the set, you can see you see subset. Set A is said to be the subset of a set B if every element of A is also an element of B. Suppose A is a set, suppose that is your 1, 2, 3. And suppose B is your what? 1, 2, 3. So we can say every element of A are also the element of a set B. We can say A is the subset of B. This is the symbol. A is the subset of B. In mathematical form, you can say A is the subset of B. X such that implies and implied by, this symbol is implies and implied by A is the subset of B, implies and implied by X such that X belongs to A. This is the implies X belongs to B. This is implies, that means if then. If the element present in A, then the element present in B. If then. A is the subset of B, implies and implied by X such that X belongs to A, implies X belongs to B. This is the implies and implied by. And this is your only implies. This is the A is the subset of B. Suppose A is equal to 1, 2, 3, B is equal to 1, 2, 3 means every element of A are also present in element of B. We can say A is the subset of B. What is the proper subset? Set A is said to be the proper subset of a set B if A is a subset of B but A is not equal to B. You see, suppose X is equal to, you say 1, 2, 3 and Y is equal to 1, 2, 3, 4, 5, 6. Here you see, here every element of X are present in Y, but X is not equal to Y. In this case, you give the symbol A is the proper subset of B. You remember, just little difference. This is the A is the subset of B and this is the A is the proper subset. Generally we use the symbol, these symbols. A is the subset. For subset we give this symbol. A is the subset of B. But in actual subset symbol is A is the subset of B. Here A is the subset of B and A is equal to B. But in this case A is the subset of B, but A is not equal to B. This is the A is the proper subset of B. This example you remember 1, 2, 3, 1, 2, 3, 4, 5. Now if A is the subset of B, implied by B is the superset of A. You remember this symbol? This is the superset. If A is the subset of B, then B is the superset of A. Similarly, if A is the proper subset of B, implies and implied by, remember this symbol. If A is the proper subset of B, then B is the proper superset of A. This is your subset and this is your proper subset, this is your superset and this is your proper superset. You remember this symbol, very important. If A is the subset of B, then A is the superset of, if A is the subset of B, then B is the superset of A, and if A is the proper subset of B, then B is the proper superset of A. Now, let us come to some properties of a subset. Properties of subset. Here you try to understand what I am teaching, but in the description you will find everything in detail. First property is, every set is the subset of itself, but every set cannot be proper subset of itself. Every set is the subset of itself, but every set cannot be proper subset of itself. You remember this. Every set is the subset of itself, but every set cannot be proper subset of itself. Second point, null set is the proper subset of every set, not subset. Null set is the proper subset of every set. You give this symbol only. Null set is the proper subset of every set. Third point, if A is subset of B and B is subset of A, implies that A is equal to B. You remember this. If A is subset of B and B is the subset of A, then you can say A is equal to B. Suppose you take A is equal to AB and B is equal to AB. Here A is the subset of B and B is the subset of A. We can say A is equal to B. And your fourth property, if A is a subset of B and B is a subset of C, implies that A is the subset of C. If A is a subset of B, that means A is inside B and B is inside C. Then we can say A is inside C. How? In diagram you see, suppose A is inside B and B is inside C, we can say A is inside C. How can you prove it? You see, logically you prove it. Proof. If A is the subset of B and B is the subset of C, we can say A is the subset of C. How can you prove? Let, you write it, let X belongs to A. Let X belongs to A. This is the first equation. As A is the subset of B, implies that X belongs to B. Because A is inside B, that means X belongs to B. Again, as B is the subset of C, this implies that X belongs to C. This is the second equation. If X belongs to A, implies that X belongs to C, implies that by definition of a subset, we can say A is the subset of C. You remember this. Let X belongs to A, as A is the subset of B, implies that X belongs to B, as B is the subset of C, implies that X belongs to C. If we consider 1 and 2, it is clear that X belongs to A, implies that X belongs to C. So you can say A is the subset of C. This is the proof. This is your fourth property. Next come to your fifth property. If a set has n elements, then its number of a subset is equal to 2 to the power n, and a number of proper subsets is equal to 2 to the power n minus 1. You see, very important. This proof we will read in chapter permutation and combination. How? If a set has n elements, then the number of subsets is equal to 2 to the power n. When we read permutation and combination, then we can find, you will see, then how the number of subsets is equal to 2 to the power n. You see, its application you see. Suppose A is equal to 1, 2. Then it's a number of subsets. Number of subsets you see, number of subsets, first your 1, next your 2, then 1, 2 and 5. Because 5 is the null set, is the subset of every set. These are the subsets. What are proper subsets? Proper subsets are 1, 2 and 5. That means you omit the set itself. It cannot be proper subset. It is the subset, but it cannot be proper subset. That means you see, if a set has here order of A is equal to 2, so number of subsets what? Number of subsets is equal to 2 to the power 2. That is equal to 2 to the power 2. That is equal to 4. You see 1, 2, 3 and 4. And you see number of subsets, number of proper subset is equal to 2 to the power 2 minus 1. That is equal to 4 minus 1. That is equal to 3. These are 1, 2 and what? 5. These are the one example. Again I am giving you another example for this case. Suppose A is equal to A, B, C. Question number 2. Find the number of subsets. Number of subsets, you see, subsets are A, B, C, AB, BC, AC, ABC and another is 5. You see it has 3 elements. The number of subsets are 2 to the power 3. 2 to the power 3 means 8. You see A, B, C, 3, AB, BC, AC, ABC and 5. These are 8. But number of proper subset, you can do it. Number of proper subsets, you see here A, B, C, AB, BC, AC. You remove this A, B, C, but it is 5. You see 2 to the power 8, 2 to the power 3 minus 1, that is your 7. Here 2 to the power 3 is equal to 8. It is very important. It will come in your exam. That is the 2 to the power 3, that is 2 to the power 3 minus 1, that is your 7. These are the number of, these are the called proper subsets. These are the subsets and these are the proper subsets. Now come to what are comparable sets? Comparable sets. What are comparable? Two sets. Suppose A and B are two sets. We can say A and B are comparable if either A is the subset of B or B is the subset of A. Then they are comparable. If A is not subset of B or B is not subset of A, then we can say these are not comparable. For example, suppose A is equal to 1, 2, 3 and B is equal to 1, 2, 3, 4, 5, 6 like this. Here A is the subset of B, or we can say, another example, we can say B is the subset of A. In this case, we can say A and B are comparable sets. Comparable sets. These are comparable. But there are some sets, I am giving another example. Suppose X is equal to A, B, C and Y is equal to 1, 2, 3, 4. Here X is neither subset of Y or Y is not subset of X. So we can say X and Y are not comparable sets. These are non-comparable. These are comparable. Two sets are said to be comparable if either A is the subset of B or B is the subset. Next come to your, these are the comparable sets. You can compare the sets. Next come to your universal set. Universal set. What is universal set? You can symbolize that U or E. That means it is the biggest set. For your consideration, you see what is the definition of a universal set? If a set under consideration is the superset of all given sets, that means we are given suppose 3 to 4 sets, and we are given a big set which is the superset of for all those sets. Then we can say for all these sets, that bigger set is the universal set. If a set under consideration, you remember this word, you consider it as the bigger set, then we can say all, and there you consider some smaller sets within it which are included in this bigger set. So for these smaller sets, that is the universal set. Suppose E is a set, it is denoted by E or U. U is equal to A, B, C dot 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 Y, Z. This is the set. Suppose you take A is equal to A, B, C. B is equal to P, Q, R, S, T. C is equal to K, L, M, N. For all these sets are included in these sets, bigger sets. So for A, B, C, U is the universal set. Universal set means bigger set. It is the biggest set. For your consideration, if we consider, suppose you consider India is the universal set. You take 2 or 3 states in one set, and you take 5 to 7 states in other sets. Then we can say for all those sets, India is the universal set. If you consider it, India is the universal set. Next, after universal set, we consider what is Venn diagram. What is Venn diagram? The diagrammatic representation of you remember, the diagrammatic representation of sets, subsets, universal sets, set operations. We will read set operations in the next topic. The diagrammatic representation of a set, subset, universal set, set operations is known as Venn diagram. That means a diagrammatic representation of a set, and it was invented by famous British logician John Venn. You see, suppose you say A is the subset of B. You can diagram, you can write like this. A is the subset of B, or you can write like also this. A is the subset of B. Suppose I say A and B are subsets of U, universal set. You do universal set like this, U. Here you take A and here you take B. Here A and B are subsets. Again, in next topic you will read A union B. A union B, you do like this. This is your A and this is your B, and this is these are all the elements in A and B. This is called A union B. Similarly, you see A intersection B, you do like this. That means which are common in both A and B. We can write this. You dot here this point. This is the A intersection B. This is the A intersection B. Similarly, A difference B, you can do like this. This is your A and this is your B. That means you remove B from A. That means this part is remained. This part is called A difference. There are a number of Venn diagrams. These are the diagrammatic representation of a set, subsets, universal sets, and these are the set operation. You will read in detail in future. So this is your A union B, this is the A intersection B, and this is your A difference B, like this. Now come to your intervals. Interval means what? Gap. Suppose in a school there is interval. Suppose your first class, second class, third class. After third class there is some interval or recess. After that other classes are continuing. So this is the intervals or gap. You see, there are 4 types of intervals. Remember, there are 4 types of interval. First one is open interval. Open interval, its symbol is like this. This is the open interval. What is its definition? X belongs to open interval of AB. This implies and implied by X such that X is less than A is less than equal to X less than B. That means here X lies within A and B, but X is not equal to A and X is not equal to B. This is your open interval. Suppose you say x belongs to 3, 7, implied what is its meaning? That means x shows that 3 is less than x is less than 7. This is the open interval. That means the x is within 3 and 7, but x is not equal to 3 and x is not equal to 7. Next come to your closed interval. Closed interval, what is its symbol? Like this. This is the closed interval. What is its definition? X belongs to closed interval of AB implied by x shows that A is less than equal to x is less than equal to B. That means x is within A and B and x is sometimes and x is equal to A and x is equal to B. This is the closed interval. This is your open interval and this is your closed interval. X is within A and B and x is equal to A and x is equal to B. Third one is semi-open. Third one is what? Semi-open interval. Semi-open interval is like this. This is the semi-open interval. Suppose you say x belongs to semi-open interval of AB. You can imagine it. Implied by x shows that A is less than x is less than equal to B. What is its meaning? That means x is lies within A and B and x is equal to B, but x cannot equal to A. Next come to your semi-closed interval. Fourth, this is your third and this is your fourth. Semi-closed interval. Semi-closed interval. Semi-closed interval, this is like this. This is your semi-closed interval. What is its definition? X belongs to semi-closed interval of AB implied by x shows that A is less than equal to x less than B. That means x lies within A and B and x is equal to A but x cannot equal to B. This is the semi-closed interval. First is your open interval, this is your closed interval, next your semi-open interval and a semi-closed interval. Suppose you see some problems. Suppose x belongs to extensive form. You write in extensive form. X belongs to open interval of 7, 9. X belongs to closed interval of 1, 8. X belongs to semi-open interval of 3, 4 and x belongs to semi-closed interval of 10, 20. What is its meaning? First you write like this. X belongs to open interval of 7, 8 means 7 is less than x is less than 9. Next come to your second question. 1 is less than equal to 8. 1 is less than equal to x less than equal to 8. Third one is 3 is less than x is less than equal to 4. And fourth one is 10 is less than equal to x is less than 20. In the reverse manner, suppose it is given 7 is less than 8 less than 7 less than x less than 9. Write in interval form. You write like this, that is the x belongs to open interval of 7 and 9 like this. So this is the first part of a set theory. This is the first part. Everybody thinks set is very easy chapter, but set is easy, but in some cases you find it is very difficult. So if you read it clearly and if you understand it clearly, then you can solve all problems of sets. And many questions come in your exam, entrance exam also. So you read this chapter clearly, because I am teaching you detail about the set. Very detail. So you read it clearly. You try to understand. Now I am doing some problems. This is the first part of set. In the next part, we will read set operation. Some problems. Suppose question number 1. Write the following set in set builder form. Suppose A is a set, that is pen, your pen. Another is your rice. Third one is your suppose Ram, and fourth one is Brinjal. How can you write it? Set builder form. How can you write? Because you see it has no defining property, because pen, rice, Ram and Brinjal, these are different. But question will come, write this question in this set in set builder form or a specification form. You write like this. You remember A is equal to X such that, because it has no defining property, because all these four are not same categories. You can write like this: X is equal to pen, comma, X is equal to rice, X is equal to Ram, and X is equal to Brinjal. If the elements are of different categories, then we can write like this: X such that X is equal to pen, X is equal to rice, X is equal to Ram, and X is equal to Brinjal. Very important question. Next question, suppose B is a set, suppose 1 by 2, 1 by 3, 1 by 4, 1 by 5, like this. Reasoning question, very important. How can you write it? You see, B is equal to X such that X is equal to 1 by N plus 1, where N belongs to N. X is equal to 1 by N plus 1, N belongs to N. N belongs to N, N means first natural number 1. Suppose you put N is equal to 1, 1 by 1 plus 1, that is your 2. Next come to your 2. Suppose 1 by 2 plus 1, that is your what? 3. Then 1 by 4, 3 plus 1, that is your 4. 1 by 4 plus 1, that is your 5, like this. So, in reverse manner, question also like this. Suppose B is equal to X such that X is equal to 1 by N plus 1, where N belongs to N. You can write in roster form or extensive form, then you can write like this. You have to consider N belongs to N means you first put 1 by 2, 1 by 3, 1 by 4, 1 by 5, like. Here you remember this question is very important. First question, if these are of a different property, if the elements are of a different categories, they have a different properties, then you can write in set builder form like this: A is equal to X or that, like. So this is the first part of set theory. In the next part, we will read about set operation. Before that, I will do some problems in your CBSE book and some entrance oriented question and some extra question also. So, if you understand my teaching, if you like my teaching, please subscribe my channel, please share. Thank you to all.